Thank you, thank you. One of the absolute favorite things for me is to spend time with innovators like you who are at the absolute sphere of innovation of AI. So thank you for being here and giving us the privilege of your time. Looking forward to sharing a lot of exciting things. Let me just get started with a conversation that I wanted to share from a few months back. One of our topmost senior technical people, we call them corporate fellows at AMD, excitedly came into my office one day and said, hey, we've been breaking our head trying to solve this problem for a key customer of ours. It was basically a kernel, deep optimization for our latest Instinct platforms. And I said, hey, here is a new college grad that produced something, and he's saying that it's better than anything that we have been able to do. A lot of people had been working for weeks on that. I said, well, they didn't believe him at first. They tried to break the piece of code that was produced, and well, after a few days of going back and forth, sure, that was true. The code was good. It was the best kernel that was able to be produced. And the secret was it was done through an AI agent assisting the new college grad. So that was somewhat of an isolated incident, call it about a year ago. But what was an isolated incident like that became a little bit more common. There were more incidents such as this. And about a year or so ago, we actually made GPU programming through AI another pillar. We fundamentally re-changed our strategy to add that as a pillar. So I want to talk to you a little bit about the things that we are doing along that vector, but also the progress that we are making on other fronts with our software stacks and so on. So let's just get started. I want to take you guys all the way back to about 4 or 5 years ago when we formed what we called then as our pervasive AI strategy. This was well before ChatGPT happened. We decided at AMD that, hey, we have all these great computing platforms, ranging from the cloud all the way to the edge and client, and we said, why don't we infuse AI pervasively across all these platforms, knowing that this wave of transformation is coming at us. And we said we would base this on 3 pillars. We must deliver a predictable, consistent leadership roadmap that has only accelerated. So we've been doing that every year to produce a silicon systems platform roadmap and delivering to the market. We also said that we cannot do it all by ourselves, and we need to partner with the open ecosystem in the entire community to be able to build alongside us. So that became a big pillar. We knew traditionally AMD for decades had been very good for building hardware platforms, but we needed to change ourselves. We needed to transform ourselves to become friendly, to become very, very easy for the open source community to build on top of AMD. So that was the second piece of the strategy. And then the third, we said that the scale at which AI is being deployed on the planet is such that we must form the deep strategic partnerships that would help us. And we've announced several, including with leaders like OpenAI and Meta, and we're on that journey to be able to build out our story. We knew also that software, particularly in partnership with the open source communities, had to be a core pillar that would anchor our strategy. And we said about open source, but we also said that we would need to leverage the rise of abstraction to be able to make the development on top of AMD platforms easier and more productive. I always joke that I have a PhD in computer engineering. You give me one of our chips that has 100 billion transistors, and well, I can't do much with it. So you really need higher levels of abstraction to be able to program to those kind of devices effectively. So I'll talk a little bit about the progress that we're making there. And then the most exciting thing, the absolute most exciting thing, is the big tailwind that we are getting with AI assisting GPU programming. About a year or so ago, we saw that general purpose programming to produce code for normal sort of general purpose computers, that was on a fast pace of transformation. When you look at what's happening with Cursor and Claude today, that's what we said was coming. And we said that same transformation that is happening to general purpose programming is also going to happen to accelerated programming, specifically GPUs. And that's the pillar that we stood up and said it would be an integral portion of our strategy. Lots of progress to share across all of these pillars. So first, starting with the open source ecosystem, a few years ago, we said, hey, what are the most important communities where AI development is happening today. And so let us go systematically enable each of these communities to ensure that programming on top of AMD platforms in these communities is going to be absolutely delightful. And I'm really, really, really happy to say that we've come a long ways. We're by no means done, but for each of these important communities, we've made a lot of progress. To give you a few examples, when we set up our partnership with Hugging Face a few years ago, if you ran a model out of Hugging Face on top of an AMD platform, your mileage would vary. Some models would run, some models would not run, and it would be a mixed experience. We said that cannot be. A typical model that exists out in the world has to run on AMD. So we set up pipelines with tens of thousands of tests that run on top of Hugging Face models on AMD platforms nightly to ensure that models will always run on AMD platforms. We worked with communities like PyTorch by enabling CI. Even in the last 6 months, we've significantly expanded CI resources to ensure that code that gets checked into PyTorch by default works well on AMD platforms. We've made a lot of development that we do upstream, and that's a priority. VLLM, for example, was not upstream last year. In January, after V 1.0 came with VLLM, we ensured that upstream development is now enabled there. Day zero support for models, that had been a priority when the latest GPT OSS model came, when the latest Qwen model came. They all are supported at or near day zero. Not only are we supporting them, but our partners are actually offering services on top of that. In fact, last year when the first of one of the later llamas came, several partners like Fireworks offered services on top of that model pretty close to day zero. So lots of progress on that, and we are continuing to expand the support of the frameworks that we support, including significant work that I'm happy to report on JAX. Pretty soon you'll find that a lot of CI that we do internally on JAX is also going to go externally. So really, really strong progress on that. And talking about abstraction, we have continued to invest at all of the right levels of abstraction. And I want to give you a few examples of the work that we are doing here. We obviously always had the lowest levels of abstraction. You can program at the assembly, or we can program at the lowest level of HIP code onto our platforms. We have strengthened our libraries by doubling down on a layer called ATER, which is highly optimized libraries that are tuned for specific workloads. For example, the most important open source models, if they have specific kernels, they're all coming by default in libraries like we produce there. We've invested in DSLs. Many of you already know about our partnership with Triton, for example. We've continued to go strong on that. And when Triton, which is a really good block abstraction programming language, introduced concepts to get greater performance with things like Gluon, we added support for Gluon, working very, very closely with the Triton team. We've also understood and recognized, based on the feedback of you and the community, that we need other Pythonic DSL layers to be able to get the right blend of performance and flexibility so that you can program to our platforms effectively. So we introduced this Pythonic DSL called FlyDSL, which gets you really, really, really good performance while preserving a Pythonic layer of flexibility and abstraction. So easy to code. By the way, it's also something that you can now use AI agents to learn from, and they can train based on FlyDSL code. And finally, we continue to invest at the higher layers of abstraction for PyTorch, VLLM, SGLang. Those communities are super important for us. But we also have invested in a layer called Atom, which is our own collection of pre-optimized kernel and model code that gives you the best performance in the fastest fashion. And you can leverage that, again, true to our overall commitment to open source. What we do in Atom is also out there. So continued investment in abstractions. Now, as excited as I am about the abstraction investments, about the investments that we're making alongside the open source communities, the greatest excitement I have about where we are going is with AI assisting our efforts. It's honestly the biggest tailwind that is helping us break down any last barriers to adoption of AMD platforms. It's helping us in two vectors. The first is feature velocity. There's always been this notion that, oh, some feature got developed on another platform, and now it's going to take a long time to port to AMD. That is just not going to be the case anymore, right? I've had some of our star developers get a team of 60 agents overnight and said, I need this feature to be available, and point at the harnesses and test cases, and in the morning the feature shows up. So the feature velocity has just picked up. Second, performance and getting the last mile out of the hardware has become absolutely easier. And I'm going to talk about both these vectors. So just to give you an example, one of our star developers, Andy, I don't know, is Andy somewhere in the audience? He's probably coding, but anyway. And Andy, I actually see him. I see him in the parking lot sometimes. He's on his smartphone, and what is he doing? He's basically submitting patches. His agents are doing the work for him, and that's a paradigm that's actually being enabled. And I don't want to embarrass people, but somebody in the front row, my marketing VP, he said that for the first time in 20 years, he's landed a PR. So, strange things happening. And then, not to put myself on the spot, I have a ROCm build going on right now. My cloud is doing something for me. So it's actually, fundamentally changed. I can do this. I can actually go back to work, and it's a really empowering transformation that's actually occurring right as we speak. Now, performance has always been hard, right? Particularly when you have super parallel architectures, lots of complexity. How do you get performance out of these pieces of hardware? What you see here is an InferenceX benchmark. I think it's DeepSeek R1. Yeah, it's a FP8 DeepSeek R1. It's a classic Pareto curve of throughput performance versus interactivity. And this is what the starting point was. This curve represents throughput at these levels of interactivity. And we have an agentic AI optimization loop that is working in improving this entire optimization curve. And just in about 10 hours, produced optimized kernels, looked at the model parameters, serving parameters, tuned them up, and lifted this entire Pareto of optimization to a spot where you get better results. This is AI optimization that's actually enabled today on our suite, and you can get the best optimization curves. By no means am I declaring victory and saying, we've solved performance, but the power of this technology and what we are able to do with this and what is coming over the coming months is honestly the most exciting thing that we have going for us right now in the development trajectory. So I want to tell you a little bit about what we are doing to enable you to take advantage of all this development velocity and AI assist coming into our roadmap. So let's start with this. Super excited today that we are announcing the AMD AI endpoint APIs. What this is it's just another level of abstraction at which you can access AMD platforms. So if you have a token gateway that you want to get set up for open models through our partnership with Fireworks, we now have that enabled. And how might you take use of that? So if you have your favorite agent framework and you have a set of API calls that are ready to be calling a LLM gateway, those models today now are possible to run directly on AMD. To tell you a little bit more about all of this and how this works, I'm going to invite one of my colleagues who is a star engineer. Mehdi, where are you? Come on up, Mehdi. Good to see you.
All right. So today I'm going to talk about a few things. One, how do you get started on the AMD developer program? Second, how to use some of the perks we just talked about, such as the developer cloud or the LLM API endpoint through Fireworks. Finally, I'm going to show an application that I just built over the past 2 weeks to kind of see how we can tie them all together. So let's take a look. So to get started, all you have to do is sign up for AMD developer program. Once you're logged in, look for the cloud credits, and this is where you actually get the choice. You can either apply for the developer cloud, or you can get your LLM API endpoint with Fireworks. So first, we're going to take a look at the developer cloud. So to do that, you'll be able to log in. You're going to see the GPU virtual machine available for you to use. So here we're going to use MI350. So MI350 is available starting soon for you guys, and you'll be able to just log in, and it's ready for you guys to use. So this has everything you need to start building. But now, let's take a pause. So the second feature that we're going to add for you guys is a Fireworks API endpoint. So with Fireworks, you can actually do a lot. Here we're going to show OpenClaw, one of the most popular projects out there, and gladly that is natively supported by OpenClaw with Fireworks. So to get that working, once you go through questionnaire, you choose Fireworks, and for the API key, you'll get access to a coupon that you can insert, get your credits, copy your API key here, and we'll have it available for you within seconds. So this is up and running, and you can do the same thing. So I'm going to take another pause. So I used the same setup 2 weeks ago to just kind of go through what we do a lot at AMD. I know Vamsi talked about it. So anytime a model is dropped, we have to go through the whole cycle of model optimization, which starts with the performance benchmarking. Then you have all those benchmarks available for the analyzer to do the analysis of all the traces. Then you give it to the next team, does optimization, writing the kernels. Finally, you verify everything, and it's ready for you. So I created the same flow with OpenClaw, where I can actually just type on my phone while I'm outside to run the same flow as I just talked about. So here's an example. So here I'm asking it to do optimization for a specific model. So what's going to happen next, there's a supervisor agent that has access to a few agents. The first one is benchmarking. The benchmark is available for taking all the model, running the benchmarking, get those numbers, create the GPU traces, available for the next agent, which is going to be your analyzer. So the analyzer has its own tools that will be able to basically take all those benchmark traces and look through ranking them, finding the source code, and making sure it's ready for the next agent, which is going to be the optimizer. So the optimizer kicks in and actually has a lot of information about AMD internal tools, such as Geek, to take a look and see how we can actually optimize the kernels and get those kernels to have a better speed by rewriting the code for AMD GPUs. And finally, there's a skeptic agent. A skeptic agent is connected to a different model, so to make less bias, and make sure that all the checkpoints are passed. And once everything is ready for you, it will report back that here's the results. And in this example, I'm showing 1.4 times speed up on one of the kernels that we had there. So this is basically me doing something, but we're more excited for you to build. So this is for you available soon, and you guys should build everything that you can to help AMD or yourself, and happy building. Passing back to Vamsi.
Thank you, Mehdi. I hope that was exciting. It's actually really, really easy to use. We've tried to really listen to feedback and said, let's just make it super easy to use. And I'm excited for you guys to try. And for those of you that are actually on our developer cloud, also excited to share some good news today. Our developer cloud has been, getting pretty subscribed, and there's always been a request to add more and also add 350 capabilities. So that's coming. So Mehdi gave you a preview of that. And for each of you that are here today, we want to offer a small token of appreciation. Look under your chair. No, don't. It'll be in your email box. There'll be a $250 credit coupon that will come to you to access our dev cloud. But also, for all of our developer friends, our developer program is growing strong. Later on, you'll see some numbers associated with that. It's really growing leaps and bounds. Lots of benefits. So if you feel like you or your friends wants to jump on, please do so. Excellent. So now we have an exciting day today. We have technical content in terms of subject matter experts. Some of the really leading voices in the space are here today. Thank you all for making the time. But also, lots of networking opportunities. So please take a look at the program agenda and take advantage of the time here. And then just to sort of step back, right? We know that AI is being pervasively infused into all forms of computing. And we also know that what is a huge amount of focus today in the cloud is absolutely going to flow out into the edge and into the client, into all sorts of computing. Recognizing that, we have been investing in our software stacks such that the exciting work that we just talked about, and you saw being targeted for our cloud platforms and Instinct roadmap primarily, is now being extended to flow into our other platforms in the client and in the edge.